Hey, 8th grade. Today we have a mid-chapter review, so we're about halfway through chapter 10, so they're having us stop and just review all the different types of problems that we've done. This one's gotten a little bit stretched out over Easter break and such, so I want to just make sure I show you an example of each of the types of problems that you'll face. You'll be doing the odds today, and I'll do an example of one like just about every type of problem that you'll see, and I'll always put the problems that I'm working on in the top corner so you know which ones these are like. So notice this is one where they want us to graph. It's been a little while since we've done these. So we want to give yourself an XY table, right? So make a quick one. And then careful, there's two other things they want you to do. They want you to compare it to the parent graph, and then don't forget to state the domain and range. So we'll do that too. I'll show you how to do that. All right, now notice we don't want to pick a value for x that would give us anything that's negative under the square root box. So we're not going to do 1 or 0, right? 2 would be fine. We can do the square root of 0. It's just 0. 3 would be fine. 4 would be fine. That's going to affect our domain at the end as well, okay? Does that make sense? So let's put 2 there. So that 2 minus 2 is 0, square root of 0 is 0. And so we have 2, 0, right? If I put a 3 in there, 3 minus 2 is 1. Okay, the square root of 1 is 1, and so times 2 is 2. If I put a 4 in there, 4 minus 2 is 2. All right, so we put a 4 in for the x. 4 minus 2 is 2. Square root of 2 is about 1.41. So if we take 1.41 times 2, we'd end up with like 2.82. We'll round it to 2.8. So you can see it's going to start to curve off, right? So if I put my dots 2, 0, right? 3, 2, and then 4, 2.8. So 4, 2.8, so you can see that it's starting to curve off. And so that should be the shape kind of that we get. All right, so now we have to state the relationship to the parent graph. So notice, remember, if there's a negative sign here, then it would be reflected. If there's a number that's not a fraction here, then it's vertically stretched versus vertically compressed if it's a fraction. Remember, if there's a minus here, it's off to the right. If there's a positive here, it's off to the left. Right? And then if you just see something added or subtracted at the very end, then it's up or down, right? So this one, compared to the parent graph, would be vertically stretched, right, because of that 2 out in front, okay? And then to the right, 2, right? If it's a minus 2 underneath the square root box, it's going to be to the right 2. So there's that second answer. So we've got our graph. And then our third answer, domain and range, right? The domain are the x values. So x is greater than or equal to 2, right? Okay, and range are the y values. All real numbers such that y is greater than or equal to 0, right? Because it doesn't ever go below that. And there we go. So careful on that 1, 3, and 5. You'll have 3 answers. You'll have your graph. You'll have what changed about the graph. Okay, like this one was vertically stretched into the right 2. And then don't forget your domain and range. Let's do one that's similar to number 11. Notice number 11's got some math and a square root on the bottom. To get rid of that, we're going to take both the numerator and the denominator times the conjugate. Remember, that's the fancy word for times the opposite. Remember that? So that's how you solve ones like number 11. So be careful. So if we do the multiplication on the bottom here, we take our two whole numbers times each other and we get 4. And then it's going to be minus because it's got a plus and a minus. The minus wins, right? And then this is really like square root of 2 times the square root of 2. In other words, square root of 2 squared. In other words, they cancel each other out. So it ends up being just 4 minus 2, right? In other words, our denominator is 2. Now on top, we take 3 times 2. That gives us 6, right? And then minus the square root of 2, because we don't have anything to multiply that square root times. So we end up with 6 minus the square root of 2 over 2. But then notice, we can divide all the numbers that are outside the square root boxes by the same number. So let's divide them both by 2. So we end up with 3 minus the square root of 2 over 1. Or in other words, 3 minus the square root of 2 is our final answer. Here's one that's like 15 and 17. Remember, when you're adding square roots, as long as the square root is the same, you can add them up. But these ones are not. So let's break them down a little bit. Notice this first one we can't break down, but this one we can. It can become 5, 2, and 2, right? So if we pull out this pair of 2's and multiply it then times this, we end up with 4 times the square root of 5. So I have 4 times the square root of 5 plus 4 times the square root of 5. Now I can add them up. 8 times the square root of 5, and we're good to go. So don't forget that if you do not have matching square roots, break them down, and they should end up matching if you do them correctly, and then you can add them up or subtract them. Probably one of the trickier ones on the assignment today is number 21. I hope you recognize that this is a FOIL one, right? We're going to take the firsts, the outsides, the insides, and the lasts times each other, and then work from there. So let's do that. Firsts, these first two pieces, we get 10 times the square root of 20. Remember, we multiply the square roots when we're multiplying, right? The outsides, we're going to take that same one. So we get negative 25 times the square root of 2, right? The insides, these two, so we get 6 times the square root of 50. And the lasts, this piece times this piece, right? So we get negative 15 times the square root of 5. All right, let's break these down a little bit. Some of these can be definitely broken down, like this one here, right? It can be 2 and 10, 5 and 2. So we can pull out a pair of 2's and then take those times that. So it'd be 20 times the square root of 5, right? This one, we can't break down at all. We're just going to leave it be the way it is. Okay, this next one we definitely can. This can break down into 5 and 10 and 2 and 5. So we got a pair of 5's. So it becomes 30 square root of 2, right? And this last one has to be left as it is. So if I pull this up a little bit, notice we've got a couple of pieces that we can combine now. Let's start with these, the square roots of 5. 20 minus 15 gives us 5 times the square root of 5, right? And then we got these two that we can combine, gives us positive 5 times the square root of 2. And we're all done. So watch out, that's a FOIL one. Just wanted to make sure you didn't miss that. Okay, these are probably the problems that gave us the most trouble the last couple of days, the ones with variables on both sides. So let's do this one that's very much like the ones you're going to face in 23 to 27. So let's square both sides. That's going to cancel out our square root box, right? So we get 3x squared minus 32 equals x squared. Okay, let's zero out one of our sides. So let's zero out this side. So let's take away an x squared from both sides. So this side is 0. So now we've got 2x squared plus 0x. I'm just going to put that in there so we don't forget that that's what we've got. Okay. Now notice, we can factor out a 2. We can divide out a 2. So we're going to do that on this one. You won't have to do that real often, but if that happens, here we go. Okay, so here's what we've got. Okay, so I'm just going to ignore this because we divided it out. We've got x squared plus 0 minus 16. Okay, and then we're going to think, all right, what numbers times themselves would give us negative 16 and add up to 0? Well, x plus 4 and x minus 4, right, would do that. All right, and so our two solutions would either be x equals 4 or x equals negative 4. So remember, our two possible solutions were 4 or negative 4, so we have to try out which ones work. So we can put 4 in. Don't forget to go back and put them in at the end. So 3 times 4 squared minus 32 equals x, or equals 4, if I want to put that in for x, right? 4 squared is 16. 3 times 16 would be 48 minus 32 would give us 16. Square root of 16 is 4, so 4 equals 4. That works. And remember, you do always need to try out both, because sometimes there's even two solutions that work. So we'll try that. We'll put negative 4 in this time. Negative 4 squared is 16 times 3 is 48. Okay, and then minus 32 gives us 16. Square root is 4, but that doesn't equal negative 4. Maybe you would have recognized that right away. We can't possibly get something that equals a negative. So the only solution that works is x equals 4 for that one. Okay, this is actually number 29. I wanted to make sure I did this one with you because it's a little bit tricky. It's finding the height of a cone is what they want you to do. And they give you all the information to pop in. So let's pop all that information in that they've given us. Pi times 3, let's just do that right away. I'm just pulling up my calculator. 3 times 3.14 gives us 9.42. So I'm just going to put that right away for pi times 3 times the square root of r squared, which we could really put in right as 9 right away, shouldn't we? So let's do that. plus h squared. Okay. So first things first, before we try to take care of this square root box, let's divide both sides by 9.42 and get that out of the way, okay? So that cancels out, and that gives us about 12.84 if we round, 12.85-ish if we round off on this side. So here's what we've got, okay? So now let's get rid of that square root box. So we're going to square root both sides. So that leaves us with 9 plus h squared over here. And 12.85 squared would be about 165.12, okay? And let's take away a 9 from both sides. Let's get that out of the way. So minus 9 would give us about 156.12 equals h squared. And then we just need to square root both sides. Square root both sides, and we end up with about h being about 12.49-ish. It's kind of what the book has too. And so 12.49, the label would be about inches for the height of that shape. So notice when you're doing problems like these, you always want to take care of what's next to the square root box first before you square everything. That makes it a lot simpler. And then once you do that, it's really just a matter of doing the opposite math on sides until you get h by itself. And there you go. So there's the actual number, 29, for you. Don't forget to show your work on that one. Pause the video if you need to go back to make sure you get all the work for that one too. Have a good day, guys.